Okay, it's time to learn about the unit circle. Okay, so why do we call it the unit circle? You can see on the screen that I have a circle, okay? And you can see that each square is at 1. So this is a graph, and you can see that it's a radius of 1 going all around. Okay, any radius will have a length of 1. Okay, that's why it's called the unit circle. So that has a length of 1. And then this radius here also has the length of 1. Okay, and this radius here has the length of 1. So all the radii would have a length of 1, which is why it's called the unit circle. All right, so let's take a look here. The basis of trigonometry will be a very special circle known as the unit circle. So this unit circle that we just talked about is the basis of trigonometry. So if you remember from way back when, we learned how to write the equation of a circle in center radius form. And that was x minus h squared plus y minus k squared equals r squared. And remember, the hk was the center of the circle, and the r is the radius. So we know within the unit circle, the radius is 1. So I know that this is going to be a 1 here. And because hk is the center, it's the origin, that in this case is going to be 0, 0. So this is going to be x minus 0, or just x squared, plus y minus 0, which is just y squared, equals 1. So the answer is option 3. The equation of a unit circle is x squared plus y squared equals 1. All right, so next we will seek to produce some of the coordinate points that lie on the unit circle from the Pythagorean theorem. So I know here that this point is just 1, 0, right? That's a point on the unit circle. This point over here is 0, 1 on the unit circle. This point here is negative 1, 0, and then this point here is at 0, negative 1. Okay, so the coordinate at 90 degrees on the unit circle is 0, 1. All right, but what if I want to find the coordinate here? Okay, then I would have to know what this angle is over here. So I need to know some special right triangles. So that's the next thing we're going to do. So we're going to start off with an isosceles right triangle. All right, an isosceles right triangle has 2 equal sides. Now, since there's 180 degrees in a triangle, these other 2 angles have to be 45 and 45. Okay, because it's isosceles. 2 equal base angles, 2 equal legs. Okay, so if we want to find the length of that x with 1 as the hypotenuse, we would just use the Pythagorean theorem. A squared plus b squared equals c squared. C, remember, is always the hypotenuse. So in this case, it's going to be x squared plus x squared equals 1 squared, or 2x squared equals 1. We're going to divide both sides by 2 to get the x squared by itself. Take the square root of both sides using that square root property, and I have x is equal to plus or minus the square root of 1 over the square root of 2. Well, the square root of 1 is just 1, so that's going to be equal to 1 over the square root of 2. I'm going to drop the plus minus because here we're talking about lengths of triangle sides, and a length can't be negative. Now, we also have to rationalize the denominator here. We can't keep the radical in the denominator, if you remember from that unit. So we're going to multiply by that radical. Okay, and we end up with the square root of 2 over 2. So in a 45, 45, 90, the 2 legs are the square root of 2 over 2. And the hypotenuse is 1, given that it's in the unit circle. The hypotenuse is always going to be 1. Okay, now remember, these are ratios. So the bigger, when you dilate a triangle, you will be multiplying all the sides by that same number. So any 45, 45, 90 is going to reduce down to this ratio. All right. So now let's take a look at the next type of triangle, which is a 30, 60, 90. Now, when we look at a 30, 60, 90 triangle, we don't know what the other two sides are. So the Pythagorean theorem doesn't really help yet because we only have one side and you need at least two to use the Pythagorean theorem to get the other side. Now, in the previous one, we only had one also, but we knew that the two sides were equal. So we could do it. So here, what I'm going to do is I'm going to create an equilateral triangle. Okay, an equilateral triangle. So each of these sides is 1. Okay, it's equilateral. Well, equilateral means that all the angles are equal to 60 degrees. Well, if this is 60 and half of it's 30, then the other is 30. So we get the 30, 60, 90. Well, if this is an equilateral triangle, this altitude is also the median. So it's cutting the base into two equal pieces. So this is going to be 1/2, and this is going to be 1/2. So the side across from a 30-degree angle is 1/2. Now we have two sides, so we can go ahead and get the third using the Pythagorean theorem. Okay, so again, a squared plus b squared equals c squared. In this case, it's going to be 1/2 squared plus b squared. B is going to be our altitude, equals 1 squared, which of course is just 1. So 1/4 plus b squared equals 1. Subtract 1/4 from both sides, and we get b squared equals 3/4. Take the square root of both sides, and b is going to be equal to plus or minus the square root of 3 over the square root of 4, which is just 2. And again, because we're dealing with lengths of sides of the triangle, it's going to just be the square root of 3 over 2. All right, so basically this is what we've learned. We've learned that there's two special right triangles that we need to know the side lengths of, the ratios of. Okay, we have a 45, 45, 90-degree triangle, in which case the side opposite, we're talking about the unit circle here, so the hypotenuse is 1. So that means the two sides are the square root of 2 over 2. Okay, then we also have a 30, 60, 90-degree triangle. And that ratio, of course, in the unit circle, the hypotenuse is 1, is going to be 1/2, and then the square root of 3 over 2. Okay, and those are very important to know. Okay, so write those down. You're going to be needing them quite a bit.